Imagine you're standing in a forest 80 million years ago. The air is thick and warm. Something massive moves through the trees ahead of you, and you freeze. But it's not coming for you. It's not even looking at you. It's looking down. At something small. Something fragile. Something curled up in a nest made of dirt and broken branches. A baby. And what that massive creature does next will challenge everything you think you know about dinosaurs. Because for decades, we pictured dinosaurs as cold, mindless killing machines. Scaled-up lizards with no inner life. Eating machines that laid eggs and walked away, the way some reptiles do today. That was the story. That was the science. That was what every museum diorama taught us. But what if that story was wrong? What if some dinosaurs didn't just protect their young, they loved them? That question sounds almost foolish to ask. Love is supposed to be a human thing. Maybe a mammal thing. Not something you'd associate with a creature that's been extinct for 66 million years, whose brain we've never seen, whose face we can only guess at from bone. But here's where it gets interesting. The evidence buried in the rock doesn't agree with the old story. For most of the 20th century, paleontologists assumed dinosaurs behaved like modern reptiles. Lay the eggs. Leave the eggs. Let nature take its course. It made sense at the time. Dinosaurs were reptiles, after all, and most reptiles today show little to no parental care. Crocodiles guard nests, sure, but many lizards and turtles simply abandon their eggs the moment they're laid. So why would dinosaurs be any different? Then, in 1978, in the Badlands of Montana, a discovery cracked that assumption wide open. Paleontologist Jack Horner found something that shouldn't have existed if the old theory were true. A nesting ground. Not one nest. Dozens. Spread across a hillside, spaced almost exactly like nests in a modern bird colony. Inside them, eggs, hatchlings, and juveniles of different ages, all in the same location, layer after layer, season after season. He named the dinosaur Maiasaura. It means, good mother lizard. And the name wasn't just poetic. The bones backed it up. Some of the juveniles found in those nests had worn-down teeth and underdeveloped leg joints, signs that they weren't yet capable of leaving the nest to feed themselves. Which meant something had to be bringing food to them. Which meant somebody was staying. Try to picture that hillside in its prime. Not silent rock, but a living neighborhood. Dozens of multi-ton parents, returning to the same nests year after year, moving carefully around the eggs of their neighbors, raising hatchlings in a crowd. Not predator and prey. Not solitary survival. Something that looked, uncomfortably, like community. That alone would have been enough to shake up the field. But the deeper scientists dug, the stranger, and more tender, the picture became. Because mothering, it turns out, may have started even before the egg was laid. Inside fossilized eggshells, researchers have found traces of medullary bone, a special calcium-rich tissue that modern female birds grow specifically to build eggshells, often at real cost to their own skeleton. Finding that same tissue in dinosaur fossils means some species were investing their own bodily resources into their offspring before those offspring even existed. Not careless reproduction. Sacrifice, on a biological level, baked into bone. And once the eggs were laid, some dinosaurs apparently sat on them. Oviraptor, a name that literally means egg thief, earned its label by accident. The very first Oviraptor fossil was discovered near a nest of eggs, and scientists assumed it had been caught stealing them. For decades, that's exactly what museum plaques said. Then, years later, paleontologists found more Oviraptor skeletons. Not near nests. On top of them. Arms spread wide, wrapped protectively around the eggs, in postures eerily similar to a brooding hen. The thief had been framed. It wasn't stealing the eggs. It was guarding them. Possibly warming them. Possibly dying right there, in that exact protective posture, trying to shield its young from whatever disaster was unfolding around it. Imagine the moment of that creature's death. Not fleeing, not abandoning the nest to save itself, but curling its body over fragile shells as the world came apart. We'll never know exactly what was happening in its mind. But we know what its body chose to do in its final moments. And that choice tells us something. So if some dinosaurs sacrificed nutrients to build eggs, sat on those eggs, defended those eggs with their lives, and stuck around afterward to feed their young in crowded communal nesting grounds, were they capable of something like grief too? This is where the science gets genuinely strange, and genuinely moving. Grief requires memory. It requires recognizing that something which used to exist no longer does, and reacting to that absence. That sounds like a deeply cognitive, even emotional, process. Could a dinosaur brain manage that? For a long time, the answer seemed obvious. No. Dinosaur brains were assumed to be small, simple, reptilian, built for instinct, not introspection. But that assumption has been crumbling for years. Modern CT scans of dinosaur skulls have allowed researchers to digitally reconstruct brain cavities with startling precision. And what they found, especially in certain theropods, the same family that includes Oviraptor and, yes, the ancestors of birds, are brain structures with well-developed regions associated with complex behavior, sensory integration, and social processing. Not mammalian intelligence. Not human intelligence. But not blank, either. And consider this, birds are, technically, living dinosaurs, the descendants of that same theropod lineage. And birds, corvids especially, display behaviors that look remarkably like mourning. Crows have been observed gathering around a dead member of their group, sometimes for extended periods, in what some researchers describe as funeral behavior. Magpies do something similar. If that capacity exists in dinosaurs' closest living relatives, descended directly from creatures like Oviraptor and its kin, how confident can we really be that the capacity wasn't already present, in some early form, in the parents brooding over those Cretaceous nests? We can't run the experiment. We can't ask a Maiasaura how it felt when a hatchling didn't survive the season. That door closed 66 million years ago. But here's the twist that should unsettle you a little. The absence of proof isn't the same as proof of absence. For 100 years, scientists had no evidence of dinosaur parenting at all, and assumed there was none. Then the evidence arrived, fossil by fossil, and the assumption collapsed. Maybe emotional complexity is sitting in the same blind spot, waiting for the right fossil, the right scan, the right scientist looking at old bones with new questions. Think about what's actually being asked here. Not, did dinosaurs have feelings exactly like ours? That's probably the wrong question entirely, a human-shaped lens forced onto a completely different kind of mind. The better question is whether the deep evolutionary roots of parental care, protection, and even loss reach back further than we ever imagined. Whether love, in some primitive, biological, instinct-laced form, isn't a recent invention of warm-blooded mammals, but something ancient. Something written into the architecture of life itself, long before there were humans around to name it. A mother Maiasaura returning to the same nesting ground, year after year, walking carefully past 100 other nests to find her own. An Oviraptor lowering its body over eggs as catastrophe approached, choosing to stay. A species investing its own skeleton into the next generation before that generation had even hatched. Call it instinct if you want. Call it programming, if that feels safer. But at what point does instinct become indistinguishable from care? At what point does a behavior stop being just biology and start being something we'd recognize, in any other creature, as devotion? We drew a hard line between humans and animals for centuries. Then we drew a line between mammals and reptiles. Each time, the line moved. Each time, the gap got smaller than we expected. Maybe the real question isn't whether dinosaurs loved their babies. Maybe it's why we ever assumed they couldn't.